My name is John Watson. I'm the Senior PCB Engineer at LeGrand Corporation up in Carlsbad, California, where I've worked for about 4 years. I've got 50 designers under me, which are based around the world. So we have basically set up our structure of our PCB design, our libraries, all that, our system and our process around being standardized and global. So I can tell you that is something I've never done before in previous companies. I've been in PCB design for 20 years. I've had the great opportunity to work with some of the legends in PCB design and to rub shoulders with them. You'll see some of them here this week. These are legends in the industry. Some of the great minds, the Hartleys, the Credens, all of them are some phenomenal people, and they're here for you to basically draw from. They're not. Approach them, ask your questions, get talking with them, and let them know what you're looking for, and start asking your questions. They will definitely spend that time with you to answer it. So. Yes, Lord. So just kind of opening up here. I was actually at the mall. I enjoy people watching. I mean, one of the things I enjoy doing is watching people. Yeah, and by the way, this has nothing to do with what I'm teaching here. So anybody who's been in any of my sessions know that I'm a loose cannon sometimes. So, I was actually at the mall and in the food court watching people. I just like watching it. I mean, it's amazing to watch people nowadays. They're always on a screen. Everyone's on a screen. Tables full of people. Everyone's on their screen or their phone doing something, Nothing wrong with that. But there was this one girl that came up, sat down next table over. She had the craziest hair I've ever seen in my life. She had every color in her hair. I was like, wow, that is unbelievable. All right. I just stood there and I stared. I was memorized by her hair. It was just unbelievable. I just sat there and finally she took notice of it. And she kind of looked over and she goes, "What, old man? What? What's your problem?" I go, "Oh, no problem. She was like, what? You never have done anything wild and crazy in your day?" And I thought for a second. I sat back and I go, "Well, there was that weekend that I got drunk, and I had a wild and crazy weekend with a peacock." I was just wondering if you were my love child from that. So she just sat there and her jaw fell, was like, "What?" So we are going to be talking about components, and welcome to university. I asked this question in the first session. How many of you have not attended a university or AltiumLive event before? These are good numbers. This is very good. Welcome. This is a yearly thing that we do now, and it's phenomenal. We actually are going. This is our third year now that we've done this, and I can tell you that this is not about Altium. This is about you. And about the next few days is going to be concentrating on you as a designer, and not showcasing Altium, and it's not going to be a 2-day commercial, 3-day commercial on Altium. All right, this is about you as a designer. So we're going to be looking at components. What is a component revision and life cycles, component creation, flowcharts. Then we're going to look at an automatic, semi-automatic, and manual methods for creating component. There's actually 3 methods on creating those. Then symbol and footprint wizards, and then conventional naming schemes, and the PLM integration of components. Okay? So, the butterfly effect. We always just, how many of you are familiar with the butterfly effect? Butterfly flaps its wings on the other side of the earth as it calls a hurricane in Florida. Okay? Well, that is really what we're discussing here, is because everything is going to start and end with your component. Everything starts in that component you have in your library. And that person that's responsible for it, that librarian, is probably the most important person you have working with you. They are the most important person. The butterfly effect, because everything then extends from that first step that you're taking on your design, is that component. And really wasn't that, the butterfly effect is the phenomena whereby a minute localized change in a complex system can have a large effect elsewhere. I can tell you that some of the biggest problems that we have had in our PCB designs have all gone back to a failure in our library and in a component. Wrong footprint, wrong numbering system on the pins, blah, 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 blah. The problems are endless. Really, wasn't that the message of Back to the Future? Wasn't that it? All right? This is not more true than with the data management system and problem. All right? You go back, you pushed a man out of the way of the car coming down the street who fell out of the tree, and now you're laying in your mother's bed. Okay, what is that? All right? Little things have big effects. I want you to start thinking about that. That's the whole point of this. Is that little problems, little things have big effects on the other side of things. And it is, if you're not careful, they will bite you in the rear end every single time. And every single time, it usually ends up costing some money. All right? Either in the fabrication, lost time, lost market, which is a huge thing right now. I just sat down with our VP of engineering, and he says, "John, we have a problem." I said, "Oh, okay, what's your problem?" You know? And he says, "We need to find a way of getting from concept to market faster. It's not fast enough. We're losing our market share because things are taking too long to develop." Okay. And that's been a big problem. If you go into your company and you ask your management about this, I think it's a discussion they're having too. Everybody's fighting for that first piece of the pie sort of thing. And they're concerned about getting their product out. Now, how many people are in the manufacturing field here? I should ask that. Very few. Actually, your company builds something. How about that? Builds, okay. All right, that's... You're looking for the market, all right? And keep in mind that when the engineering team gets into practice and they get into their R&D process, they're looking for market share. They need to get their product on the shelf to sell it. Because guess what, guys? We don't get paid. And I tell my engineers, my PCB people, this all the time. You don't get paid for engineering. You don't get paid to design. And they go, what? Whoa. No, you don't get paid for designing. This company exists to sell product. We build stuff to put on a shelf for someone to walk in and to buy it, and then then we're done. That's where the money comes from. But you do not exist just to build. The company exists to sell stuff. And that company is looking for market share, and they're looking for quick time to market. And when we don't have our process down correctly and we allow things like the butterfly effect into our process, game over. Okay? So the last session, how many of you attended the last session or did not attend the last session? Shame on you. Shame on you. All right? No, just kidding. Singularity, management, architecture, reproducible, and traceability are your 5 pillars that you have to build your library on. All right? Then that's what everything of your components are built on. And that then becomes what your PCB is built from. Okay? Singularity, managed, architecture, reproducible, and traceability. So what is a component? What is in a component? Well, years ago, it used to be a schematic symbol and a footprint. That's all you needed. Right? How many of you guys have taken like a resistor symbol and like let's say it's a 402 resistor, took the same symbol, copied it, and changed the value? It used to be a big practice. Just copy and paste, right? The resistor that you needed, just change the value. Well, that's not very good practice anymore. Why? Because there's different components, parts of a component. You gotta get the right button here. There's 2 sides of this. There's your information side now, and then there is your models. Octopart says they have 13.8 million components available to their consumers. That's a lot of parts, okay? But every single one of those parts fall into these 2 categories. Every component will have an information to it and then the models. In the information side, you'll have the name, description, your parametric information, which is all the details about that component. You have your sourcing information, which is who is going to be your manufacturer of the component and who's going to be your vendor, your supplier. Keep in mind, you're going to have both of those. You're going to have a manufacturer of your component and a supplier. And then the other information is your data sheet. So that's your information side right there. So now, this is why you can't just copy and paste a resistor symbol anymore. That resistor could be a different parameter. It could have different information. It could have a different sourcing. It could have all these different informational components attached to it, which are different. Now, we got away with this in the early days. My goodness, I sound so old, you know. Hey, in my day, we used to sit in a black room in front of a light table. And we used to sit there and we used to use this thing called Mylar and tape, you know. Yeah, we used to do it. Yeah, we sure did. And so we came up with some interesting designs and shapes of traces too, you know. The other side of this is your models. So this is your parametric this is your informational side and your model side. Under your models is going to be your symbol for your component, your footprint, your 3D model, and your simulations. Now, understand, there may be some additional other items involved in there if you want to throw those in. There's, but those are the main ones that we shoot for. So here's your symbol, for example, your 3D model, your footprint, and then the simulation models that would be a part of that. So this is your full package of a component. It's a lot of stuff, huh? This is a lot of information. As we looked at in the last session, we saw that the process, the PCB process, begins with like a starting information, and it goes in and it becomes an output for the input for the next stage. So this then is your output information for your library. This is how you would then structure your component to be the output for your input to your schematic. What would be your output for your schematic then? Your net list, right. You're pushing that into then the PCB, okay? Your PCB, that output becomes an input. That input then, you go through that process, that stage is your PCB design or your layout. What then is your output for your PCB? Your Gerbers, output, your finish, your finishing documents, okay? So think of the process like in that way, or stages of inputs and outputs. And keep that in mind as you're looking at stages of your design. We found it much helpful for our designers when they realized, I'm doing this stage of my design. These are my inputs. These are my outputs. This is what's expected as my outputs. And each of those stages then are verified as a part of the process. Have I verified my Gerbers? You'll see when you start breaking down the PCB design process is that schematic. There's verification for that stage. What are the verifications? Well, there's ERCs that you run. What are your verification for your PCB design? Well, there's my DRCs that I run. Component level, you're going to see here that there's actually a component review process that you can take your reviews through, your components through. Each stage has a review process that you don't move forward until it's been verified. Your outputs have been verified. Okay, so break up this whole process, because I tell you what, it's a long, tedious process with thousands of steps to design a PCB. And if you break it down into stages and understand, here's your inputs and outputs, outputs, it structures that much better for you. So here is your input and your output. Your outputs these are your outputs for your component. So each of these areas, though, you have your information and your models actually go into different roles. Not everybody, for example, in your PCB process is going to be interested in the same information. So now if you look at it, you can say, well, my electronic engineer here, he's going to be interested in my parametric information, my data sheet, and maybe the simulations. Okay? To kind of give you a contrast, my procurement or my mechanical engineer, he's not interested in my simulations. That's not his role. When you mix into the process here all the roles then of who does what and what information they use, you start breaking this down. Oh, okay. My electronic engineer is going to be looking at the parametric information, my data sheet, and the simulations are going to be run. The librarian does a lot of work with most of these things. Mechanical engineer, what's he looking at? Well, he may be looking at the data sheet, and he's going to be interested in 3D models. When that information is pushed over to MCAD to verify the mechanicals, that's what he's going to be interested in. Is my mechanical engineer interested in what symbol was used? Oh, no, he's not. What's he interested in? The 3D model. That's the information he's going to be passed over. So keep this in mind, that different roles in this process are going to be using different information. So as we saw in the last session, we have a management plan for our components. Our revisioning cycle, our life cycle, our roles, and our permissions. So we have, for example, our revision. Every time you touch, in Concord Pro, every time you touch a component or change a component, the revision is bumped. If you start with revision 1, for example, it's going to be bumped up to revision 2. All those revisions are going to be saved, so nothing is lost. So keep that in mind, that your revision cycle and your revision control of what you use in your components is very, very important. We use a base, in our components, we use a base revisioning cycle. 1, 2, 3, 4, 5. It's very simple. Also then is your life cycle. Every component, you think about it, every component that we presently have in our system has a life cycle and someday will die. It will go through an end of life. Every single component will do that. So knowing and looking at the signs of what your life cycle schemes are and how that is gone. Now, the normal life cycle scheme is that you have in a new component, a released or verified component, and then as that component's used, you'll start seeing some warning signs that it's coming to the end of life. At that point, then it goes down the other side, and then it's end of life, and then it's out. I would say that when you start seeing those warning signs is when you should be starting to pull back and start redesigning, not using that for new designs. Because it's only a matter of time. Once it starts going down the other side, I don't see too many components that reverse course and go back. I haven't seen very many of those. Am I mistaken on that? No, I think most of us have seen that once something goes down the hill, it goes down. Yeah. Quick question?
Just for clarification, this is in terms of like part performance or just like in part availability?
A part availability, yeah.
So what about like, let's say for example like through-hole resistors, like the ones where you like give to like little kids to teach them electronics, like
Yeah.
those aren't going away anytime soon. Like
Now I'm feeling really old.
Yeah, exactly. Yeah. They won't go away, but they're not going to be used for mass production, though. I mean, they're going to be a situation where if you're building 100,000 boards, for example, for units, it's not something you want to put through-hole components through. I mean, even the equipment that's used.
yeah, I'm aware like that's like the reason why we don't use them in like industrial applications.
Yeah.
Right? I should just clarify, has there ever been an edge case where that is preferred for massively produced products?
It's what?
Has there ever been like an edge case where you would want like product like that with a very extremely long life cycle?
Probably not. No, I mean, even for us, we're looking at reducing the size of our boards, and so understand, component manufacturers are in business to stay in business also. They will put out products. If they see a product line that's not producing a lot, they'll phase it out. They'll go ahead and phase out. And what you're seeing now is you're seeing a lot of larger component, even surface mount components are being phased out. The 1210s, the 1206s, the 603s are even starting to get a little etchy, you know?
Our procurement is having a hell of a time trying to source 0603.
There you go. So, I mean, because the mentality that is, well, I can put a 402 and save space, less board, less FR4, blah, 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 all right? Less everything. There are the pros and cons of that, though. Keep that in mind with engineering it. You have your wattage and you got to watch for, make sure you're not, misdesigning that. But understand that you're going to have a life cycle to that component, and a lot of those components are going to be phased out. So end of life. Now roles is then you're going to be setting up the roles and understanding who does what and what permission levels they're going to have. Not everyone should be a librarian. You should have select people that can do certain things in your PCB design process. But we're going to be concentrating on the librarians today. So here's an example, very subjective to your company. Here's an example of a revision control of a build. So this is an example. Concord Pro handles this very well. This is one of those things that you want to set up beforehand, guys. Don't shift gears after you get 1,000 components in and realize, whoops, we had the wrong revisioning scheme here for the thing. So think about where your company's going to be in 10 years, 15 years, how it's going to grow, and how this system would change with that. You want to make it where it's flexible enough to change and shift as your company grows. So don't set it in and fix it into a set pattern that it's not flexible enough. You understand? So we have for us, we use a number, major and minor, for some of our items. Not everything will have the same. Same thing with your life cycle. We basically have a levels of major and minor revisioning in our components. We don't have the minor, I'm sorry, in our components. We have just the major. We just 1, 2, 3, 4, 5. Our projects, understand, not everything will have the same revisioning scheme. Not everything will have the same life cycle. So you got to kind of sit back and go, okay, in Concord Pro, we're going to have this, this, and this. This is our revisioning scheme for this, this, and this. All right. Also, probably keep this in line with your PLM systems, as we're going to see in this session. We're going to see that we actually have a PLM integration that we can use. It's very efficient to simply follow the revisioning scheme and the life cycle they've already set up. All right. So you can also then set up your content type of these are all the items that Concord Pro handles. Okay, it's not just about components. Keep this in mind that it's not just about components, but you can also set up that revisioning scheme for what each of those that controls, okay? So common scheme for components, life cycle schemes, is you have your prototyper, your introduction. This is more of a lot of times on the manufacturing side, but then also as you get it into your system, you're going to be wanting to have a life cycle for this component. What we usually do is we end up having new, released, end of life, obsolete. That's kind of a standard life cycle pattern that we follow. And we basically just run this component through there. So keep in mind that as your end of life happens, now you may have varying times that you've got to work with. Meaning if you start seeing end of life signs that a component is dying off, you may have a month, you may have 6 months, you have a varying time after that to get a replacement for that component. Fortunately, what happens here is this. You can do a where used. You can pull up any component in Concord Pro and you can select where used. And with that then, you can then see where every single unit is going to be impacted. And this is really efficient for us because what we can do is we actually pull up that component, say where used. Okay, we got these 4 units, for example, that's going to be impacted. We place them onto a revision, design revision, and we then go from there. So it's really, really helpful.
So in the decline portion of the curve,
Yeah.
how do we find indication of that?
Okay. That's a very good question. How many of you guys use Active Bomb? Okay. We use Active Bomb a lot, and there's been that's one way of determining whether something's coming end of life. There's some questions that have come up regarding about how they come up with that, because a lot of times if you go into DigiKey, they don't have an indication yet that it's showing end of life. But what we found is that the algorithm that Altium uses somehow kind of looks at multiple vendors. They have 750 vendors I think they look at, and they look at more of a broader picture than just DigiKey, for example. And you can't always just judge a component availability based on one vendor. So they look at a lot of vendors and look at that availability and make sure, okay, and then they kind of do an algorithm to determine, okay, this is starting to flag. I think what they do is they look at quantity, build quantities, they look at different items in that test, and they determine that, okay, this is not recommended for new designs. It's being phased out. As soon as we see that first indication, that warning, we kind of put a flag on it to say, okay, just watch this, all right? So it's something we just watch. And what we've seen is, I've actually had engineers come back to me. I just had it this week where an engineer came back and said, well, DigiKey says they have 10,000 of these. Okay, all right, we'll run with this.
This week.
What?
I said this week.
This week they have 10,000, right. So I kind of look at it and I kind of say, okay, we'll run with it. And what I've always seen now consistently is, they say 6 months down the road, it comes back and they go, oh yeah, you were right, you know?
Just for clarification, this happens at the decline point.
What's that?
So when like a product is marked not for new design, that's right at the beginning of decline or somewhere.
Yeah, right in that area. You'll start seeing where there's a couple levels. You'll see an active bomb where you put your bomb in and it will get a report back that says, okay, this is not recommended for new designs, or this is now entered into the next step, which is your end of life. Then it goes into obsolete from there. The component is obsoleted. Now, I work with China. I work with designers and procurement people from China, which is very interesting. Very interesting. Because you say, you know, what's that?
That's a good word.
Yeah, it's interesting. Because I had this situation, I'll give you a story on this. We had this situation where we were looking for some crystals. Well, they were coming to end of life. Okay, instead of replacing them and replacing the design, you know, updating the design, what we did was the procurement people in China go, oh, by the way, we can get these crystals, no problem. Yeah, okay. And I warned them. I said, beware of that. Just because you get components doesn't mean they're good components. Doesn't mean that. And it turns out that they were counterfeit. Yeah. We put them in our units. They were not correct. They were counterfeit. And we ended up biting the bullet. We had to pull all of those units back, everything else. Yeah. We did not, we hoped for the best and it didn't work out. Not everything will have the same life cycle. Yeah.
How do you handle the parts which are manufactured on consignment?
Oh, with what's what?
Manufactured on consignment, meaning the part is not available to open market,
Yeah.
but you have an agreement with the manufacturer that, okay, for the next 10 years, I need 50 million of these every year, and they need to be for me. Nobody else can jump on that stuff.
That's sweet, man. That's a good deal. That's a good deal. So you're the guy who took all our components. Yeah. Okay. That's true. Believe me, I speak a lot on. I'm going to be speaking tomorrow on Thursday on part problems and part shortages. Yeah, it's assignments is. That's where you kind of manually go in and say, okay, no, that's, even though for the real world, we'll call it, the life cycle situation doesn't exist for us.
The part doesn't know about those situations.
Yeah, right. So, yeah, that's a kind of you're on your own on that one. I mean, yeah. I mean, you can label a component saying, okay, yeah, we're not changing our life cycle because we
Integration is important because that's the PLM guys.
Yeah, exactly, and that's what we're going to discuss here. So yeah, these components, life cycles, are a major issue, guys. I mean, we all struggle with them right now. So in this life cycle situation, you can set up any life cycle you want just simply by adding the next stage here. You can then give it an indication of saying, different levels, different things like that. Just understand, this is something for the administrator to sit down at the very front. How many of you have actively using Concord Pro now? Okay, so this is something which you're wanting to get started or wanting to get set up. So one of the so far we've got some organizing to do in our libraries, our structure. We're sitting down and saying, okay, what is going to be our revision cycle for this and our life cycle for the components, and be able to sit down and calculate that all out. So this monstrosity here is a flow chart of what we came up with for creating components. This is what we put out to the librarian and how to then create the component. The structure here is driven by the process. These two here we'll go through these in more detail, but It's basically where everything starts here in the fully automatic method. Then what's left goes into the semi-automatic method and then into manual method. Your first choice is to do it automatically. And we're going to see why here in a second. But this is your flow chart. And don't worry about scribbling this all down. This is going to be on video and a part of the training module that will be released, and you can go review this again. Anybody who wants this, though, I can also give me your name and number. I'll be glad to email this to you. I'll be glad to email the presentations directly to you, actually. Okay? I did a lot this is the third year I've done this. Did a lot of emailing last year of the modules, so feel free to do that too. I'd be glad to work with you directly on that. So this is your flow chart. Pretty intense, huh? So you have 3 methods for creating your component. You have your automatic method, your semi-automatic method, and then your manual method. Try to keep it up here in your automatic method, and we're going to go through all these here in a bit. But where you start out with is your prerequisite. Every component you start with, these are your prerequisites. You want to know what part number, category, and family that you're working with. A lot of times you'll have an engineer that says, I like to use this part. Okay, that's great. So then you pull that part up in Octopart, and it will tell you then the category and the family of that component. Now you got your vital information to start with. What is that? What you're building and where is it going? What am I building? I'm building a 2N20202, whatever it is, okay? Then it's going to go into this category and the family. The next part is, though, a component search. You want to, librarian and whoever's responsible for this actually, you want to make sure to do a very exhaustive component search to make sure that you're not repeating this component. This component may have already been created. You may not know. So knowing whether you got this component or not based on the manufacturer part number is very important. So here, for example, is a page from, this is from DigiKey, and looking at your prerequisites here. So here's a page, we're looking at let's say a redriver I2C single channel chip here. So what would be the category? Integrated circuits, right. It wasn't a trick question, right there, categories. Yeah, there you go. And what family? Well, the family right below it. It's the interface signal buffers, repeaters, and splitters. Okay? So there's your manufacturing part number, your category, and you know your family now. So this answers those 2 big questions. What are we creating and where is it going? So in our library then, we have the situation where we have our category, and point it out here. This is your category for us. Understand this will be different in yours. But our integrated circuits, and then down here is we have our interface signal buffers, repeaters, and our splitters. So all the components that are in this category and family are put there. That's its home. Pretty basic. Pretty simple. All right? So the category, if you notice the numbering system, we use a numbering system. You don't have to if you don't want. We find it pretty convenient because keeps it in a position instead of alphabetical order. So we just set up our number family and our category and family numbering system. So we have the 100s, and then the single numbers are the families. So you can have endless categories, endless well, not endless, of course, but you know, you have a lot of categories and you can have endless families that you're involved with, and then endless components under each one of those. So this is how you can organize all this information. So the question you have to ask yourself now is this a discrete with a known footprint? And we're going to discuss how we handle the discretes because that's something different. Under each one, under the 900 integrated circuits then is a model folder. So a model folder for each category. I did say I think it might be better now to have a single model folder. So at the bottom there at the bottom of all your categories, you will have your model folder for your schematic symbols, your footprints, your simulations, your 3D models, all that. I think it would be a change I would make on a new system if we were to do it. To just have a single model folder rather than model folder for every category.
You said you have people working from all over the world, right?
Yeah.
They're all making their own components?
No.
You have one person that can make
No. We have 3 librarians. We have,
only those 3 people can make components?
yeah. Yeah.
Okay.
Yeah. So all the requests go into one of those 3.
So like if they're, the 3, I mean, are obviously in pretty good communication and stuff, like, I'm just wondering how you avoid it. They use a different source than DigiKey, like how to, like that might use a different like family set, like how you
Well,
avoid.
DigiKey's really good at this. Is they set up their category and family. So one of the first things they do is they'll go into DigiKey, type in this part number, and everyone will go to that same source of information. What we've done now is we've switched over to Octopart because they provide a lot more sourcing for the component. Understand, DigiKey is a vendor, a supplier. So what we've done is we've done Octopart, which does multiple suppliers of that component. So if you look at this page in Octopart, it's a lot more information of who can provide this component. So we've kind of switched over on that. But the same setup though, category and family. Also understand that Altium has their own category through their manufacturing part search. They have their own families and category and families also. So take a look at that. That's a very good structure also. Something I worked with Altium with when they first were bringing in the manufacturer part search was to make sure they had that category and family set up. It's a way to organize your components. Just putting them in one big bucket is not going to work. So, all right. So let's look at the fully automatic method then. What you're going to be looking at here is this. You're typing in and selecting the manufacturer part number, all the models, whether all the models come in, yes or no, and then any models are duplicated. So one of the very first steps is that you select then your family, you select in your current category in your family and your situation, and then you simply say add the component. So this is what comes up then. How many of you guys have seen this before? Okay, this is what will come up. And as you type in that part number, the list will come up. The list of components. It will start filtering out the components that are available based on what you're typing in. Right up here, right there in that name. So as you can see, the final selection there gets pulled in. All right, so that manufacturer part number is right there. And what happens is that all this information automatically comes in. It took like 2 seconds. It's like, wow. And we did this with BGAs, and it's beautiful. It's very powerful.
Is this only in Cloudform Pro? Or
No, this is in Altium right now. This is. What's that?
What's the source? Where's that?
I think that comes from the cloud, and the cloud's up there. No one fully understands it. It's the all-knowing, seeing cloud. No, seriously, it's probably from Concord Pro because it's our source of information with Altium. So a lot of that comes from them. That's a good question, though. I got some developers here, so I'm going to talk to them more about. They haven't let me peek behind the curtain very much. So
They get a lot of it from Octopart.
I think so. Yeah,
They're pretty well partnered, you know,
with Octopart, you're right.
and a lot of that information comes probably sourced from
Forget the name of it, there's another library.
Siva?
Yeah,
Yeah.
the guy's really great. If you have a part, they don't have the thing, they will make it for you.
Yeah.
In 24 hours, you've got the footprint and everything.
Right.
And they do a nice job of creating oddballs.
Right.
And so I'll just say one thing that we started, and just kind of go back a little bit with Bulk, because you guys have been doing it for a while too.
Yeah.
Where they have the components kind of templates, and you say you have to put these things in. So before
Right.
this didn't exist until the last couple of versions.
Right. Right.
You
Exactly.
had to put in those things. So the problem we're having now is, and even going forward, that the parameters that we put in don't match what's coming in.
Right.
And then sometimes this gets from different sources, which is why I think it is coming from Octopart.
Right.
Their parameters may be labeled differently.
Right.
So now when you go to match or something that says min temp,
Yeah.
if I want to look at a resistor, then I'll go to, I don't know, 155.
Yeah.
It's in 4 different parameter columns, like scattered all over our libraries. Now we're trying
Right.
to figure out how to get all that back together, so just as a word of caution.
Yeah.
I
So
noticed that too. We ran into exactly.
Yeah.
Because we've been using templates that we had from day one.
right.
No two people, it seems, use the same. Okay,
Yeah, exactly.
Maximum temperature range.
Yeah.
Whatever.
What we did was, if we go back here, under, not in this one here, but there's parameters for each of the components. What we did in the previous versions of all this is that we went into a DigiKey, we pulled up that component, a sample of component in that family, and all the parameter information then we copied, that became our template. And then whenever we brought in the information, let's say we opened up a component, we then copied that parameter information, we switched it over to Excel, copied it in there, we then shifted it over to columns, and we pasted it in. We had manually copy and paste. Everything had to be brought in. So all this information that came in, all this parametric information had to be put in manually. And it was, you could copy and paste it from DigiKey. That's how we did it. But still, it took a long time. I mean, compared to 2 seconds that all this stuff is brought in. Because what you have here is you have here all the information you're looking for. Remember, the component is made up of what? Information and models. So here, you have all the information you're going to be needing. Here's your name, your description is brought in, your parametric information, your sourcing information, who's going to provide this component. Then you have your schematic symbol, your footprint 3D model, and there's 3 of these. There's going to be 3. There's going to be the nominal, the least, nominal, and max. Okay? So we're going to be talking more about the...
Under part choice as well, that also show equivalents.
no, I think what you would have to then do is add any of the other...
Because sometimes what we ran into is some parts that are available on the wheels of 5,000 or wheels of 10,000. And it's
Yeah.
just the suffix that changes in the manufacturer ordering code. So
Right.
you want to have both of them in there.
Yeah. So keep in mind, yeah, you want to keep... you can put alternate components in there also.
Doesn't come in automatically.
Not automatically, no. So it's going to be based on the manufacturer part number that you originally put in, yeah.
On really the same sort of tangent there.
Yeah.
I mean, you're showing 3 different footprints.
Yeah,
Is that correct?
yes,
So then my experience is, again, it's usually some sort of a suffix or at least a 3-letter code
yeah,
that defines which package this is going to be in.
right.
SOIC.
Well, that's the same package, but there's 3 different IPC standards, right?
3 different IPC standards, yeah. Well, the nominal size, the size of it is not going to be, it's 3 different packages. So, but I have to look and determine how they handle that.
Because typically what we've done now, I mean, I've noticed that you can associate multiple footprints
Right,
with a particular package.
right.
Typically, we've been just saying, okay, screw it, we'll just put it in a separate part number.
Yeah.
SOIC will be this, and
Right.
ESOP will be that.
Yeah.
So,
So for example, this is the SOA package, not least, nominal, and max. Okay, the same footprint, the same thing. I think what it is more of the placement courtyard and the details of the component.
oh, I see, you're going to the courtyard.
Yeah, yes. So, but this is automatically brought in. So this is what you want to shoot for. Okay, this is really what you're shooting for, is your automatic method. I keep trying to tell Altium, guys, some of us do work by the hour out here. I mean, we have to come up with new excuses why things took so long. You know, it was hard entering that part number in the name field and, you know, waiting the 2 seconds, and, you know, it was tough, you know. And so now there's a little bit of maintenance that you want to do here. You want to select, if you have 3 footprints that come in like this, what's going to happen is if you bring those into your design, and when you push those out to your PCB, it's going to ask you what footprint you want to use. Well, okay. So you can actually then set up a default. Which one is your first choice? So we used to go ahead with nominal. We'll set that up as our default, and you'll see that little symbol come up next to it that shows this is going to be your automatic choice. So just keep in mind that even though all 3 footprints are there, you will have a default set up for it. The other 2 are just sitting there. So if you need to adjust then the density of your board, which just happens a lot of times, you can go in and select the other choices. Okay? Yeah.
I'm just getting confused about what's going on. You say part creation now, is this pulling information from like that sheet, coming up and creating the part, or is it something that's already been created out?
It's already been something that's,
Importing the product?
it's the latter. The latter.
The system I was telling you about, it's not seed, it's Symantec.
Yeah. Understand that not every component, we're going to see here that not all the models are out there, not all the information's out there.
I use this Symantec system.
Yeah,
Create the models, create the footprints.
right.
But it's just a quick question, maybe it's just so when you're doing the checks of your library compared, you know, to your design here,
Yeah.
like obviously you're not using the default.
What's that?
The design check and comparing what's current in the library to your design,
Yeah.
is that able to flag up if you're not using the default?
No, I don't think it does. I mean, the default will be your go-to choice. You'll have to manually go in and change it if you want another one.
Well, yeah, I get that. I'm just thinking of review.
Oh,
You know, it's like
yeah.
for review time. Are you using a special footprint anywhere? Maybe you need to go out and design it. You know, just like
Yeah, this is a good point. It might be a nice little addition to a note for that. So the very first thing you need to do is make sure you set up your default. So whenever you're using multiple footprints in a design, or when it comes in like this, when it automatically creates, you want to make sure to mark one of those. Otherwise, you're going to get the warning sign when you push this over to your PCB. Oh, select your footprint you want. All right. Also, then you want to select your target folder for this. So each of these new components, you need to select your target. There is a default, and this is the reason why I think I've gone over to a single model folder. This is a setting that you can set up in Concord Pro that will actually, you can automatically just put the items there. Your footprints, your models will automatically go into that folder. With the way that we've got it structured, is we have multiple model folders. We can't do that. So if you have a single model folder, this would be something that would automatically be set up for you. You simply push it out and it's good. So that's not a concern. So keep in mind that these are models that are going to be coming in. Okay? You may already have them. Okay? Let's say you put in a resistor, a 402 resistor, and you put in that part number and it brings in all the information. Well, you don't want to have multiple symbols for a resistor or a multiple footprint for the 402s. These are searches that you're going to have to do. All right, and make sure that you're not pushing too much information into your library. This is a little bit of a check that you need to do to say, okay, even though it created it, I have a few people. I have one lazy librarian, I called him. I said all he did was just plug in part numbers all day long and just, okay, we're good. Without doing this, and we ended up with models that we'd already had. Okay, we ended up with new 402 models. We ended up with resistor models. All those different things. Make sure that you're checking and make sure that those footprints do not already exist. Okay, so what you can then do is you can actually remove the footprint and select the if you go back, let me go back here. So here you can actually select these and remove them. Remove the footprints that you say, okay, yeah, I know I've already got this footprint. We're good. You select those, remove them, and then all you do is you select the new footprint and drop and drag it. You say, okay, yeah, these are the 3 footprints I want to use. And just make sure you do that step. It's very important.
I got a quick question.
Yeah.
All your footprints then in just one folder for everything for your entire
Library.
all categories, all families.
Yeah, I would recommend that. I mean, that would be a change I would make on our library. We set it up as having separate model folders for each one. And maybe someday we'll be able to consolidate all those together and have one place for them. But we'll see on that. So this is here. Make sure that you remove and replace your models if you know you've already got them. This is where Altium has now become so powerful that it does a lot of work for you, but it may be work that you've already done. Okay, so keep that in mind. So the semi-automatic method is down here. So so let's go back. Should put in a master here. So here, what we walked through here was this. You're typing in the part number. All the models came in, yes. Any models are duplicated? No. You move models to the target folder, remove and replace the other models. Now, what happens though if not all the models come in? This will be the situation, okay? So what you have to do, if you conduct a model search, you find the missing. So what you do here is, let's say it just brings in your symbol. That's the only model it brings in. So when you type in your part number and you hit enter, well, it brought in your symbol. That's great. So what you have to do is you basically, if you already have the models, you simply pull them in. It's a part of that process of replacing them. You simply go out to your libraries, pull in your models, and then drop them into your footprints. And with that, then you have your design. I have not seen too many situations where the information is not brought in. If I'll tell you what, if I do a search on a component and nothing comes in, that may be a component I don't want to use. All right? Because that means it may not exist. Okay, so if I have information that doesn't come in, I'm very seriously looking now and I'm thinking, Where's this component coming from? It doesn't exist out here in the world. And believe me, Octopart is powerful enough to give you whatever information you're looking for with your components. It's very, very powerful. We have a lot of Chinese vendors that we work with. All right? And let me talk a little bit about that. We have a lot of Chinese vendors that we work with that if you type in their part number, you're not going to get it. I'll tell you what, I've gone to some of them that I type it in the world, into the internet, and I still don't get it. All right? I still get nothing on this part. I would make some recommendations regarding working with international sourcing. All right? We have the situation where we're both domestic and international. Have two sources for a component. If the China group wants to use a Chinese manufacturer, that's fine, that's perfectly okay. But have a cross-reference to a domestic source. Don't leave it hanging out there where the only source you've got for a component is some Chinese group. That group could go away, that could disappear. Now you have no information. You got no information on that component. You pull up the data sheet, it's in Chinese, okay? Fortunately, we've got people in our office who can do that and read Chinese, but I haven't quite got up to speed yet on my Chinese. I'm still a little weak. So have two domestic sources. Down here, in the sourcing area of your component, make sure you have you can put in their sourcing and your sourcing, okay? Domestic sourcing. So have both. It helps also then to provide replacements and give you the information you need if you ever have to replace it. So make sure that you're setting up your default and your schematic, for example. This was a new component. The schematic, make sure that you're setting up your default folder. I'm sorry, that's your footprint, your 3 footprints, setting up your default. And then this is a new feature here. Whenever you now finish, came in, I think, in Altium 18, maybe, somewhere around there. But you can now do component rule checks. You can check your components and set up design rules for your components themselves. This is phenomenal, guys. This is where we actually can set up the design rules and make sure that all our components are correct. And so here you have simply right-click. Here, you make sure that your component, why am I pointing? I get this thing. Make sure that your component is saved off, and then that will activate your component rule check. All right, so then you can, all the messages or any problems that you have will show up in your message window.
Where do you define what it should be?
Those are going to be under your preferences. Under your preferences in your library, that is where you can then set up. If you go up here, I don't think I put it on this slide here, but in your preference area, there is under there a component rule check, and that then is where you set up your rules, what will be applied, and it has the same sort of setup that is, you can either make a warning, fatal error, vital error, problems like that. 4 different categories of an error issue. So this has saved us a lot now when we basically have rule checks that we can set up, and we then check every single rule. We can check every single component, make sure that they're correct. So let's look at here the fully manually creating a component then. This could be the situation when you type in that part number, and all that comes in is this. All you're going to get is the part number, the description, and the parametric information in your sourcing. Only the information. The no models will be loaded. Okay? It's going to be a tougher situation. I just love it when you type in the part number and all the information pops in and it's like, oh yeah, there we go, right? Would only place new models in the library once an exhaustive search has been done. Only do these sort of things after you've searched, okay? Search, make sure that you're not manually creating something that's already exists. If you come up to your librarian and they're creating a resistor model or a schematic symbol, you should be asking them, what are you doing, okay? But make sure that they're not already repeating the work. I've actually trained our librarians to do a lot of work searching, just searching, how to search and do things like that. And we're going to talk a little bit more about how to do that later. All right, so how do we then create a new symbol? Let's go through the symbol first. You go to New, and what's going to happen is you're going to have, whoops, wrong button. You're going to have the work area open. This is very common. It's going to open up in your Altium side. And you then basically create your symbol. All right, these are the guidelines that we kind of follow. We have a pin length. We have the name and number here. We then have on grid. Make sure that you're on grid on your pins. On grid, a 10 or a large grid size. Some of the biggest problems I've seen with schematics is that the pin was off by like 1 mil. Yeah. What's that?
We've been in this big time. Some designers decided to do this, and
Okay, I do metric. So I'm a metric guy. I think it's such a great system. It's a perfect system. Divisible by 10. Come on, guys. Why can't we not solve this issue? I'm going to go on a rant here a little bit. I was told as a kid that in school, now that was many years ago, that, oh yeah, in 10 years we're going to be switched over to the metric system. Yeah, everything's nothing. What are we doing, you know? Who came up with the 12 inches being a foot? What is that? I mean, really? Come on. I love the metric system. It's the way we do everything. The one rule with that, and I will tell you this, is if you start in one, do not switch over. Okay? If you start a PCB in metric, stay in metric. If you start in imperial, keep it in imperial. The reason is every time you switch over it rounds off. It rounds off. It rounds off. And pretty soon things start shifting in your design because you keep switching back and forth. All right. I find that metric is just the way to go.
yeah, we do that as a design for the layout.
Yeah.
Big question we have in the schematic. Why does he use the metric versus
Yeah.
but it did because when you're on grid, some designers are already in there on like the imperial grid.
Right.
Then they said that schematic is metric, and then half the stuff was off the grid, half the stuff was on.
Right.
And the schematic doesn't matter.
Yeah. But I would say so, yeah. I mean, there's a gentleman walking around the convention. You'll see him, Mike Creedon. How many of you know Mike? Get to know this gentleman. He's top notch. His big thing was grid. Grid. All right? Everything is on grid. Keep it on grid. I've seen it where schematic, when you place this component, where if the grid is off, you do not put grid, you don't have it on a small grid. You keep the grid big. So you're laying things down on grid. So these pins will be on grid. So when you place your wire, the wire will be on grid. Okay?
I'm actually surprised that you use 10 because we've got a lot of problems with 10. You have to zoom in really close to see if things aren't connected.
That could be adjusted. I mean, I think we are adjusting this. I think this is an old slide. That's a good point. I think it's something where that should be increased.
And
Yeah,
So you have to change the grid, otherwise you get things off grid.
right.
You have to use that.
But you'll see it immediately when you start working with it. So make sure your electrical hotspots are out here on your schematic symbol. I've seen them where they've been on this side and somebody made a connection, like physically viewing it made the connection, but it wasn't because the hotspot was over here. You want I'm talking about the hotspot on the end of the pin? Yeah, set up each electrical type of your component. This here is just a rectangle. So a line width, these are kind of the guidelines that we give the librarians to make sure that, okay, every component's going to have the same standard, that we say that they all should look the same. So here you're creating lines. Now, a great feature of Altium is that if you're in the middle of a process, you can hit the tab key. You're going to go into a pause situation and then go into your properties. From there, you're able to, what is called the floating. You can actually, that's done by hitting your tab key. You can change any of your properties then about that issue that you're holding there. So you can actually go in and hit your properties and different things like that. So keep that in mind. And then basically you then hit the play button again and you're back into live action, what I call live action. Okay? Try to make sure that you keep that hotspot. Make sure where you've got this hotspot. That has caused more problems. Because if you're doing a huge design with thousands of connections, you're not going to catch it. You're going to look at a schematic, you're going to print it out, and you're going to do the old highlighting line by line sort of thing, and you're going to see, yeah, that's connected, but it's not. Okay? Because the hotspot was not in the right position. So once again, see where the butterfly effect's coming in that I talked about when I first started? Little things. The butterfly flaps its wings, and you end up with a hotspot over here. Causes massive problems. Okay?
Do you not use the built-in electrical error checking?
Yeah, that would.
Because we've used to never run that.
Oh.
And we've had redesigned.
Well, you like living on the edge.
We had several things turned off. One of them was floating pins.
Yeah.
It is very common to have like an FPGA with 200 floating pins.
Oh my goodness, yeah.
And so we would just ignore that rule, but we force people have to run it because we've had one pixel off.
Yep.
And so, I mean, that's what we do. So
Yeah.
just now, and then there's a directive you can set to ignore DRC on this pin.
Yeah.
And you
Right.
have to put that for every NC pin you have.
Yeah. Exactly.
Every other pin doesn't get flagged.
Right. So keep that in mind. So then also make sure you're setting up your designator, your information. See how much more difficult this is when you're doing it manually rather than automatic. It's like much more difficult. So footprint, same sort of thing. Is we have the footprint, pads, 3D models, silkscreen, all the different parts of this component. Okay, every single one of them has to be laid down. So I say that a lot of times I see components that are not done correctly. This placement courtyard, the part origin, the placement courtyard, the green area right around here is not put in. And you think, well, okay, well, you know, it's no big deal. It's just a placement courtyard. But it's really important. It's really vital. Part of the reason is that helps the PCB person when he's laying down the component to say, okay, here's my component. Here's how close I can get the next component. This is where I can put my components and how close I can get them. If you violate that rule, you may have some assembly issues or assembly problems. Now, there is also the other great plus about the placement courtyards. For extra credit for your test that you have to take at the end of the class, everyone knew about that, right? All right. Oh, you didn't know? You have to take a test? Oh, okay. So, what is another purpose of the placement courtyard? Huh? Assembly prints. Okay. Usually that's actually another layer that you put your assembly information on. Now, let me give you a little hint. If you know the if you know the placement courtyard of a component and how much area that component's going to take up, couldn't you calculate then every one of those components you're going to be using on your board and determine what would be called a density feasibility and how much space you're going to need? How many times have you gotten in the situation where you laid components on your board, started routing, and you realized, uh-oh, my board's not big enough. My board's too small. Now you're in trouble, right? This is something that we do. If we have a question regarding our density feasibility of our board, how dense our board's going to be, we do a density feasibility. This is set up on a grid. Notice here the placement courtyard is on a grid of 0.25 millimeter, okay, 0.5 for larger components. Everything's on the grid. Meaning that I actually have a Excel spreadsheet that I have all this information in for all my footprints in that Excel spreadsheet, where I simply type in how many of these I'm going to be using. How many 603, how many resistors, how many capacitors am I going to be using with this footprint? And then it comes back with a number. And the IPC says that your board, that number should not be more than 65% of your board area. Okay? If it's above 65%, that means that you're going to be pushing it. They don't recommend to go above 80% on this number. You forget it. You're going to be out of a room at 80%. So this is a way for you to determine, all right, what density feasibility you're going to have on your PCB. So that placement courtyard is actually very important. And I have actually seen it where, like I said in the previous session, was that when we saw manufacturing problems and issues, we found also that sometimes it was because these placement courtyards were placed too close together. Components were too close. This dictates how close you can go. All right.
Is that part of the design rule check that will automatically look for that courtyard overlap?
I don't think so. I think that would be a great feature to have, because what they can have then is say, look, these are our parameters we're looking for. If the rules right now for the component rule checks are not the same as it would be for a PCB. A PCB, you can set up unary and binary rules. It would be nice to have the same thing here. All right, to say, in my placement courtyard on this mechanical layer, I'm looking for this. All right, make sure that I have my 3D model. Make sure I have this, this, and this. Make it more parametric information rather than just go or no go. That would be great.
You said you have a spreadsheet that has all your courtyards. Is that something you manually generate, or is there something you can extract out?
No, that's something I created. I held on to. That helps me with my density feasibility. If I have a question about whether our board's big enough, I sometimes run that just to make sure that I'm not pushing my board. So then once again, once you've set up your footprint, your schematic symbol, your footprint, you select your model, your folders. Okay, this one's going to go into the footprint. That's a symbol. All right. Once again, you go run your rule, review, and release. Then you simply go save it, do your rule check. Any of the problems or issues are going to show up where? In your message window. And then your can be released. Okay? So now let's talk about wizards. Your second option here is that you can actually use the wizard instead of the doing it manually. How many of you use the schematic wizard? Okay, a few of you. That's good. Very, very helpful. And I would actually highly recommend this. This is how we kind of we don't manually sit there and type in, all this information. What what this wizard does is it really kind of consolidates it into a single step and helps you to organize it and to do this. So the one thing I will say about wizards is this: it's the downside. There is a downside to using wizards, and Altium has a lot of them. If you ever worked with Altium and the wizards, how many of you learned to drive? How many of you know how to drive a stick shift? Okay, most of us. How many of you don't know how to drive a stick shift? Just automatic. Okay. If you learn to do things automatically, automatic is pretty easy to learn, to drive. You actually have to relearn when you do things manually. All right? I know some folks that do things automatically, and that's the only method they use. And they don't understand the manual process of doing it, of doing something. I actually recommend them to learn manually how to do this rather than just pushing the button and doing it automatic, okay? At least know that. At least have your librarian and your people to know how to do something manually before they just do it automatically. Because what they'll do is they'll just go ahead and push the button, next. Okay? So here is a schematic symbol wizard. And in here, you have basically your setups. How many pins you're going to have, what is going to be your designations, your electrical type, your side that you can have. Up here, you can actually then select your layout that you want on your symbol automatically, so then it will change this. So a lot of times in your data sheet, if you pull up a data sheet, they will tell you what the type is right here, for example. Most all data sheets have this information for any chips or anything else like that. So it will have your type set up here, but this is where you would change this automatically. All right, you would just come in here and say power inputs or whatever. And then it just creates it. It creates that symbol. And then putting in your designator and your description of your schematic symbol. Okay? Very, very simple. Everything is right there on that window that you're looking for. Yeah?
So just to be more helpful on that too.
Yeah.
When I've used that before, if you're doing like a 900 pin FPGA, you can get the parameters set up in your Excel spreadsheet.
Right.
The same way that they're wanting them in there.
Yeah.
You copy from your Excel spreadsheet right over it, and paste them, won't count them all the way down.
Yes.
And
Right.
that's very helpful. And then you can just change that over there instead of when you screw up. You gotta start over.
Yeah, exactly. So the skill that I would highly recommend for you to learn, and two keystrokes that every one of you is going to need to know: Control-C and Control-V. All right, let me go over that again.
Then Control-Z.
Control-Z when it screws up, right. Control-C for copy, Control-V for pasting. Control-C, Control-V, all right? For the old DOS people here. All right.
V is even more useful because that's smart based.
Yeah. So let's look at your footprint wizard now. IPC compliant wizard. There's been some question that who brought up the question about it wasn't compliant with. Okay, was that you? Okay, I'll need to look into that. This may not be up to date with what is the latest IPC standard, but they usually try to keep this up to date. This is the footprint wizard. And one of the first steps is that you want to select out what type of component you're doing, what footprint you're going to be looking for. And then in the next panel, this is where you put in your measurements. And in your data sheet, you can actually pull those up, drop those pins in. The one thing I always keep, and it's kind of hard to see down here, I keep it clicked was be generating your step model. Automatically generate your step model through your wizard. It does a very good job. And as you're creating this, this will change based on what measurements you have here. So learning how to read your part and measure how your part's measured out is very important. So once again, some more information that the package dimensions, different things like that, your pin, your shape. This is actually going to be basing the component footprint on those measurements, okay? This is why it's so important, especially this here is your thermal pad inside. If you have a thermal pad on IC, your package heel spacing, different things like that. Does everybody understand on footprints about the pins? You have your toe, knee, heel, knee. That's what this is here on a pin, on a component. And actually one of the most important places on this component is on the heel side, not the toe. People think it's a lot about the distance of your pad, like out here, but it's not. It's really about inside between the heel of your body and the heel of the lead and your body. That's really where the strength of your component is.
I had a voltage regulator with the inside the body that had a pad for heat and such.
A thermal.
Thermal, but it was also ground.
Okay.
And I was using an auto router simply because it was really simple.
What? Another one who likes living on the edge. Wow.
Only for very simple movements.
All right.
And 90% of the time I end up redoing a lot of it anyway.
Yeah.
But it gives me an idea of how.
Okay.
When I created that component, and I created it with vias, you know, that goes down below.
Yeah.
But each via was labeled as ground, and the thing wanted to make a separate trace to every single ground point in that pack.
Yeah.
And I put 6 of them, you know, because I want a good distribution and, you know, solid connections to the bottom for playing.
Right.
Is that a design rule thing to set it so that it doesn't fly around every single ground that's not there? Because the whole pad's ground.
Yeah. I think instead of, I don't know if this is an area, if that pad is an area of copper or whether it's a pad. There's two different ways of approaching it. You can lay a copper down or you can lay a pad down of that size. So the pad should connect up. Yeah. You put an area of copper. Yeah. Yeah, put the pad, not the area of copper. So all right, so this is one of those rules that I actually have my librarians know very well. I want them to understand what creates that pad shape. And if you talk to the Hausers of the world, Tom Hauser, he's an expert at this. I would highly recommend you go on his site, Tom Hauser Components. Very, very good. This is an understanding of how the physics of developing of the fillet, the solder fillet, on the lead is going to be done. And it's basically on a formula. Okay, if we have this much area of the toe, the heel area, this is going to need this much pad to develop this much fillet. Also then the height of that, the thickness of that lead, how far up it's going to go, different things like that. So very, very helpful. And then this is where you would set up your medium, lower, and high density. So here also then is setting up your tolerances. This is just where you go next. So place fabrication tolerances, your placement tolerances, and your courtyard excess. This is where all those numbers are set up. So then the footprint has, this is your footprint dimensions. Just giving you a warning that it was trimmed a bit. This is where you would put in a rounded or rectangle pad. I've been using rectangle or rounded pads for probably a year now. Once again, silk screen set up, and then you're done. Okay, you're finished. So that footprint you just created, right or wrong, is right there. Okay, keep that in mind. That's dropped in here. Setting up then your target where each of these two new products are going to parts are going to go. The symbol is your footprint. Okay. And then you go through your design review component, you save it, do your component review, and all your package. So you're now finished. Now, a little discussion here on discretes. One of the things that we saw was that we had a lot of components that we were repeating. Right? You go in and do a discrete, for example, or a component or a capacitor, and you would go in and you say, well, I know I got the capacitor symbol. I've used it 1,000 times. I know I got the footprint symbol, okay? So one of the things that we did was we actually set up a component template. So what you do here is that we set up a component like this, and we use this kind of nomenclature up here where we say resistor 0603 with brackets on the end. Okay? And we then brought in the 3 footprints we want to use and the symbol. And then what we then did is that we then saved that as a component. So if someone goes in and say, yeah, I'm creating a 603 resistor. Well, we know we got that. Okay? So we saved a lot of time by just having them go in there. They searched on this bracket, the bracket with the resistor 603 on it, pulled up that template. But keep in mind, what you want to do is when you go in here and you say, okay, yeah, there's my 402 template, for example. All these were our templates. Our operation, you don't want to edit this. Don't edit it, because then what were you doing? You're editing your template, okay? You don't want to do that. Leave the template. What you want to do, though, is clone it. Give me a copy of this. Okay? Then, what you then do is you do the normal process of creating the component. You put in the part number above there. It drops in, and it's going to ask you, okay, do you want to use all your information or just the parametric information? Just pull in the parametric information, and then you leave the models as they are. It's a really cool trick. Saves us a lot of time. So when we know when we're going to be creating a discrete capacitor, and you could create these models for any level you would want, actually, when you think about it. If you have, discretes, inductors, your capacitors, your resistors, for sure. We have models all set up for them, templates set for them. So any of the other models that you could bring in, say, yeah, these are going to be our 3 common footprints we use. Or if common footprint or symbol and a symbol, just go ahead and use them. It's a very big time saver there. So set those components up. So don't have much to say about conventional naming systems. Keep a conventional naming system, guys, though. Because what this all means when you're doing searches is if someone called a 402 resistor, hey, Joe's special part, okay, guess, it's not going to work, okay? Just try to keep a conventional naming system, whatever that naming convention is for you, and just keep it running because it's going to be important for searching and finding stuff. As your library grows, and as our friend he has 17,000 components in his library. I can imagine the searching power, what goes on in there. You know, this finding stuff is phenomenal. But there are some great articles in Altium regarding naming conventions and different things like that. IPC also has some very good material for you for naming conventions on the footprint themselves. Okay, if you noticed here on this 3D here, it actually gave you a conventional naming convention for this component. A TSOP, and then there's based on the size of the footprint and number of pins and so on. So there will be a conventional naming system here. 7351 of IPC gives you a great source for that, for naming. I've seen some really nice, tricky things regarding schematic symbols, where different symbols, a lot of times when you pull up a data sheet, it will have a base number and then a multiple, let's say it has 5 packages for that part number. It has then part numbers, symbols, and a lot of times we divided up our symbols based and named them according to what package type they want to. So in the data sheet, it will say that this package type would be letter D, prefix, V, C, and C. We put that in the name. So we say, okay, here's your base name for your schematic symbol, and these are the packages that would be in that schematic symbol itself. Because a lot of times you'll have a 5-pin part, 8-pin part under the same data sheet, different material. So just keep that in mind with the naming conventions. Okay, let's look at real quick the PLM integration. This is, how many programmers or anybody familiar with XML have we got? A few of you, very good. You guys are the ones I want to talk to because I'm not a software, I'm not a programming guy. I'm just, you know. But this is an XML file. It's rather simple once you get into it. But there are 2 main parts of this. There's going to be the instance and then the scheme. And what you do here is this is your setup for your URL connection to your PLM. So this is actually how it connects up. Now, in the latest version of Altium, they now have down here a workspace area that they put in, the version 3. We have a situation in our company that we have multiple workspaces, and that's what brought this on. I work directly with Altium and their developers, and what issues we have with our package. So I'm kind of like the beta testing them. And one of the problems that we had was this. We have a component, we have 3 PLM systems, 3 different PLM systems. So that single component will have 3 different part numbers, all based on our PLM system. Whatever work area that the company's working from. Now imagine the headaches involved with just 1 PLM. We got 3. All right, and I told him, I said, automatically we need to have the instance, but we then also need to have a selection of workspace. What workspace we're going to be concentrating on. So that was actually brought in here. And that's where that's set up right there. So the rest of this program, the XML, the scheme is actually rather simple. This is based on Altium type capacitor and the PLM type. This is a bidirectional program, guys. This will push out information over to Altium and push information from Altium back to, from the PLM back to Altium and vice versa, okay? So this is all set up based on your component type. So in Altium, you'll have a component type here, and then in the PLM, you'll have its component type. So this may be some merging issues here also, keep this in mind, but if you have different component types set up in your PLM versus your component type it gets a little hairy there sometimes. So also then, as we're going to see in the next module after lunch, is we're going to see here, you're actually also then able to set up your projects so that when you run your PLM, you actually can then you'll push this out over to the PLM, and the PLM will respond back with part numbers for your project. Pretty cool. The same thing here is that the capacitors, this is example for 2 of these, capacitors, diode. So every one of our component types that we would have in our library, we then set up. Now, in this information then, you have a bidirectional process. All right, so you actually have 2 parts of this. So we're looking now just at capacitors, for example. You can say to PLM, do we want to sync to the PLM or to Altium? Which direction we want to go? Or both directions. So in that then, you can then set up a code or the numbering system that you're going to be using. So what you want to do is you want to say, okay, yeah, I have in my PLM right now all my capacitors. The capacitors is an electrical code, a prefix of 160. All right, that can all be done here in the XML file, where the PLM category and then the prefix or suffix codes are put in automatically. So that's pretty cool. So here is kind of the structure, if you can visualize this. This is the information. Here you've got information that will be pushed over into Arena. So when we run this, we basically push in we get notice that we have a new component. We work with Arena in ours. Okay. Now understand they are adding additional PLM systems all the time. Okay, so just because you may have a particular PLM system, don't feel as if you're out of this. You will have this opportunity. And then the XML file. So here, what we're doing is we're pushing out here, and we're saying, okay, this is a new component. This is the product line description. We're not pushing very much information out here, but this is the information that's syncing up with. Now, PLM is coming back, and they're doing a PLM part number. All right, so that's the information right here. So we have in our Altium, we have a PLM part number. We have our 3 divisions are this. We have WattStopper, Vantage, and QMotion. Okay. So our PLM information, we have 3 categories like that we've got sitting there. 3 fields in our parameter field. So what we're doing is we're pushing out to a workspace, and we're saying, okay, we're creating a new capacitor in our Vantage workspace. Okay, this is our basic information here. And they're coming back, and they're then dropping that PLM information into an attribute of the location of that for the PLM number for Vantage. That's what we're doing. So we're basically just pushing information, a certain level of information out, and then we're asking for information back from a communication back from the PLM back into the component, and that's being automatically done. So now there's a couple special considerations here. When you push out from Concord Pro the components, you're going to have components that match up according to your PLM number. Those then get synced up. Any changes on your PLM side would then automatically be pushed into your Altium side, and vice versa. Now, there's going to be a certain level unmatched components that you're going to have new components created in your PLM, and you're going to have unmatched components that are going to be created in Altium. Keep this in mind. So these 2 big packages, we had to be very careful when we first did this sync up, that we didn't just say, yeah, create all these new components in the PLM and create all these new components in Altium. We did it in stages where we had to deal with packages of data and packages of components at a time, okay? Because you don't want to just go and create your XML file and push the button. All right, that's like living in the danger zone right there. All right, it's just so keep in mind that this whole what's happening here is that if components are unmatched, these components will be created in your PLM, and the components unmatched here will be created in Altium. Very dangerous situation. Now you may have duplicate components. So take this one step at a time when you do this. So you match this. We ran this, saw what components matched. We then said this. We did this stage of it with new components, and the legacy components were pushed in. And what we did was we actually took all the components that were brought in from the PLM into into Altium. We put them into a separate folder and a separate location. These were components we had to work through, and our librarians are working through now. Okay, so that's it. All right. Questions? Yes.
What's your single point of truth when you have two PLM systems? And I think you have a single AltiumLive, right?
Yes.
You know, and you've got all these, you know, attributes with everything in there. You know,
It gets hairy.
conflict.
It gets hairy. Yeah.
So what's your approach and strategy to that?
I usually go with the one that has the most components. That would be our WattStopper, our WattStopper environment. We have 6,000-7,000 components in that. The other ones have, Vantage I think has 2,000, QMotion has 1,000. So we're trying to shift over to a single PLM system now. It would be much better, and the reason is for that very reason. Is that you need to have a single source of truth. All right, so
So in that now, single PLM,
yeah,
you know, and your library, you know, when it comes in, sometimes it comes in, you know, from, you know, manufacturers, like, hey, you want to use this?
yeah,
And it comes in sort of via sort of PLM route.
yeah,
You know, the design side of it, and then bring that in first, do sort of the and then pushing that back.
right, exactly. I mean, you've got to keep in, what we've done is that we've actually then pushed, we also then have fields in our PLM system for each of the workspaces. We've got the other information for the other workspaces. So we'll have Vantage's part number, QMotion's part number, WattStopper's part number, okay? So we have that information there. Because this is an automatic process, we can actually pull that information from Altium that's there and push it in and pull it back out. So we basically start syncing up this information as it goes along then. It's very difficult at the very forefront when you're trying to get this up and running, especially with 3 PLM systems. It was very difficult for us because now you have multiple information, different things like that. But once it got synced up, it was very, very good, very good. So it was like if they go in and change anything on the Altium side, we get noticed of it. The PLM side, it gets pushed into Altium. There's now a complete sync up of all this information, which is really great.
Yeah, so follow up to that, you know, the life cycle piece of that, you mentioned the piece of that, and I'm sure like when you set up the life cycle with the library, they can kind of line up this life cycle.
Yeah,
PLM system.
yeah.
So your system, who's in driving through the life cycle?
The
You know, minimum, so, you know, okay, we've released it
yeah,
in our library, so we can use it as part of the system for ECPA design.
right.
But
The
PLM system may decide, yes, but we're not very excited.
yeah. What drives that life cycle is a lot of what drives that is the Altium side now, because we tie that into the active bomb, and that gives us a lot more live data information. So just to know that things are changing. So guys, thank you very much. Any other questions? If you have any other questions, feel free to grab me. I'll be here all week.